Assalamualaikum and good morning. I am Abir bin Rahman Bhuiya. Welcome to my PSM2 presentation video. PSM2 is Project Sarajana Muda 2 Final Year Project 2. My supervisor is Dr. Sitihaja Uthman and I am doing research-based project. So this is the table of contents. Here I am going to talk about the research topic, problem background, research question and everything related to the research until the suggestion and future works. So my research topic is food picture detection using convolutional neural network CNN. So the problem background is food has evolved in today's fast-paced world from being a means of substance to something to be shared, documented and enjoyed. We are all eating food and we are going to the different restaurants every day and we are taking different types of food. Everyone is taking different types of food. So food related applications and websites offer a wealth of information and services, while social media platforms are flooded with attractive food images. The development of food image detection system throughout this digital food revolution has been crucial in improving our dining experiences and resolving several issues. These systems analyze food pictures, extract patient data and offer insightful analysis using cutting-edge technology like computer vision or machine learning. For example, the modern Chinese diet is being driven by the quick advancement of computer technology. The growth of mobile internet diet, on the other hand, is based on artificial intelligence technology, which has been integrated with every element of social life. So, the need for fresh farms in the catering industry has led to an increase in application situation and a need for more precise technical specification very least. The diet industry with the traits of the new age has high research value in its application scenarios and offers an innovative ideas for the growth of the mobile internet diet industry under the combined action of technology support and social necessities. So my research question is how food picture detection can be implemented, how to predict, detect and develop food picture detection by using CNN with TensorFlow, and how to test and validate the performance of CNN to detect food pictures. So the research objectives are to investigate and identify all components, performance, features, parameters, etc. required to perform CNN techniques for food picture detection domain, to propose CNN enhancement algorithm for predicting food picture detection, and to test and validate the CNN enhancement algorithm methods using food picture dataset from Kaggle and Google Colab. So the research scope is no existing adaptive architecture effectively gathers and analyzes food images, nor does it logically follow the evidence previously gathered to guide food search operation. Instead, a convolutional neural network architecture for collecting and monitoring data to identify food pictures includes a set of circumstances and consequences that specify how images and technologies interact. This research will use the CNN along with Kaggle Food11 dataset to identify which system is to interact with locally as an acceptable guiding system analysis for the detection of food images. The datasets will be based on varieties of food pictures, where will be two types of directories for the system. One of the directories is train, which will be used to train the model, and another directory will be test for testing the model. When used to improve the CNN model, CNN concentrate on certain areas such as the detection of single meal and cannot be used to identify incorrect photos without unbalanced diet, utilizing Google Colab and Python to discover the successful conclusion test and validate the improved model. So this is the literature review that I have done. And this also shows the comparison of approaches and results from literature. Here we can see so many authors used computer vision system, machine vision system, and optimal wavelength selection method, and monochrome computer vision system, and we can see the accuracy here 87%, 97.9%, 97, 84%, 97.88%. And also this is the continuation of the computer vision. We can see here use RFID and multiple kernel learning, and this is deep convolutional layer, this is average pooling, residual architecture. So there are different methods used by different authors, and we can see the accuracy percentage here. So this is the research framework. It is a very basic framework which I start with the identify the problem and case study, literature review, identify appropriate method and algorithm, apply and the appropriate method and algorithm, evaluate the performance and implementation. I also have the phase explanation here. So this is just the basic framework which helped me to do the research, and this is the research phases that I have done. Start from the problem background and the review. I have reviews like machine learning, ANNs, SIFT, RFID sensor, and different classifier, computer vision, and CNN model. I have reviewed these techniques and compared these techniques and investigate and identify the capabilities, and I did identify the gaps, and after that I define the research scope, and then I obtain the dataset from Kaggle data 1.1, and then experiment I have done, and then result evaluation, and then the achievement and future work and the report contribution. So this is the way my research was done by different phases: phase 1, phase 2, phase 3, and phase 4. So the experiment tools were Kaggle dataset that I used, CNN model for the algorithm development and research, Python programming used for the CNN model, and I used Google Docs for the documentation and Google Colab to run the program. It actually worked as the IDE, and TensorFlow, it's actually a library, so it's the coding tool. So this is my experimental tools. For the hardware specification, the processor is used Intel Core i7, RAM is 8 GB, and hard disk 1 TB and 56 GB SSD. So the parameter and the testing method was for the computer vision, the experiment 1, I have checked the accuracy, false negative, false positive, and CNN model, the existing CNN model, also the accuracy in both terms, and for the enhanced CNN model I have also checked these methods. So this is the experiment design, computer vision. So we can see the basic algorithm here. So set the random seed, create a model, and then compile the model, the matrix, and then feed the model. And then this is the existing CNN model. Here we can see the import the TensorFlow library, set the seed, import image data generator, and then process all the pixel values, import data, and build the model, and then compile the model with the matrix and feed the model. So here I can show the CNN model enhanced. So I use the runtime, it's GPU. So import the TensorFlow library and also the data generator, set the seed with 42, and then also the pictures, and set up the paths, and then import the data from the local machine, and then build CNN model here with more the Maxpool 2D and the Conv 2D layers with more layers added to get more accuracy, and then the kernel size was specified, and then different metrics with feed the model with 5 epochs. So this is the IDE view of the computer vision model. Here we can see the TF is equal to TensorFlow, and seed the global random seed, and Keras is it's actually high level neural network. And this is the CNN model. Here we can see the existing CNN model. So kernel size is actually the height and width of 2D convolutional layer, and Conv 2D is the 2D convolutional layer. And this is the enhanced model. So here I have added the extra pooling layers. So pool size is actually window size, and padding is given, and the Maxpool 2D is actually the TF layers, I mean the TensorFlow Keras layers of Maxpooling 2D class, and to the flatten used to remove all the dimension except for one to make the picture to identify. So the research achievement is the study endeavor has 3 main objectives in view. Since the whole result and classifier performance cannot be fully generated in final year project 1, so everything is done in final year project 2. Based on the result of the classifier, all the objectives for the second and final project have been met. The improved CNN model for detecting food performance well and studies workflow can be used to develop the improved model. In addition, in the classification procedure successfully varied the differences between the existing CNN model and the improved CNN model. So this is the suggestion for the improvement. As we know, CNN have made outstanding progress in the field of food photo detection. There is always more room for improvement. So few suggestions are expansion of the data set. We can expand the data sets to get more accurate or different variety of food categories to get more different accuracy level and fine-grained food classification. So from here we can divide photos, precise subcategories, and even identified foods cannot be explored in future study. This can be done with the fine-graded food classification, and multimodal fusion function can also help to improve the work. So this is the references that I used, and thank you so much for watching my video.